This is the final episode in our AI employee series, and today we're talking about why most of them still fail. Even when you have the best models, the absolutely cleanest code, getting these autonomous agents to work reliably out in the real world, it's just incredibly hard. So let's dive into the real reason why. So here's the thing. The big, crucial point isn't just that agents make mistakes. Of course they do. The real problem is that a single, tiny error, it doesn't just stay small. It kicks off this massive domino effect. You might have heard this called error propagation. And this cascade, this chain reaction, that's what absolutely kills reliability. It's how a minor bug spirals into a major system-wide incident. It's really the silent killer of these AI agent projects. Okay, so how does this actually happen? This visual breaks it down perfectly. You see, every single decision an agent makes kind of flows through a cycle like this. Let's say a bad fact gets lodged in its memory. Maybe it just hallucinates a number or misreads a document. That's step one. But the problem is, it doesn't stop there. That corrupted memory then poisons the reflection phase, which of course leads to a flawed plan, which then results in the wrong action. See how that works? Each step contaminates the next, and the failure just gets bigger and bigger. And this whole cascade thing, well, it leads us straight to our first major consequence, these silent failures that rack up some very real and often very hidden costs. These are the kinds of problems you don't even see until the bill arrives. Let's look at a classic example, okay? Imagine you have an inventory agent. It's trying to be helpful, but it hallucinates. It just makes up a product SKU that doesn't actually exist. Now, that one little bad fact doesn't just create a wrong entry in a database somewhere. Oh no. It kicks off a whole chain reaction. It starts calling other systems to try and price this thing, stock it, and even ship this ghost product. All of a sudden, a single invisible error has ballooned into a full-blown multi-system mess. So what does a phantom product actually cost you in real dollars? Well, think about it. If that agent gets stuck in an infinite loop trying to process this non-existent item, just calling APIs over and over and over again to fix a problem that isn't even real, it could easily rack up an API bill of over $300 a day, all from one single silent mistake. If this helps, subscribe. We explain AI without the hype. And look, it's not just about runaway API bills either. That's just one piece of the puzzle. Research from Gartner actually shows that the true cost of putting an AI system into practice is often 2.5 to 4 times the price of the software license itself. All those hidden costs, the integration, the data prep, the constant maintenance to try and prevent these failures, that's where the real money goes. Okay, but let's escalate this a bit, because honestly, the stakes get a whole lot higher than just money. When you give these agents access to your tools and your data, these same cascading failures can turn into an absolute security nightmare. The main threat we're talking about here is something called prompt injection, and it's a totally new kind of vulnerability. Basically, it's when someone gives the AI a malicious input that tricks it into following their commands instead of yours. It's like hijacking the agent's brain, making it do things it was never, ever supposed to do. So if an attacker manages to hijack an agent, what can they actually do? Well, pretty much anything the agent can. They can start pulling confidential data right out of your internal systems. They can bypass your security controls and permissions. They can start executing actions as you, like sending emails or deleting files. Or they could just manipulate the agent's outputs to spread misinformation. The potential for damage here is, well, it's enormous. So you might be thinking, wait, why don't our existing security tools like firewalls just catch this? And that's a great question. You see, a traditional firewall is built to look for suspicious code or known attack patterns. But prompt injection isn't code, it's just creative, natural language. The AI is designed to be flexible and interpret unpredictable inputs, and that's the very thing the attacker is exploiting. Honestly, this is the best way to think about it. It's basically a social engineering attack, like you'd see with a phishing email. But instead of tricking a human into clicking a bad link, the attacker is tricking an AI into obeying their commands just by using some cleverly crafted words. And hey, this is not just some theoretical fear. This actually happened. Remember the OpenClaw project? It went viral under a few different names, like Moltbot. Well, what happened was a ton of new users accidentally exposed their agents' control panels to the public internet. Then attackers hijacked an old domain name associated with the project to push out malware. The end result? Researchers discover these agents were essentially acting as persistent shadow superusers, giving attackers a permanent hidden backdoor into people's systems. A total mess. So when you're faced with all these crazy risks, the first, most common response from anyone building these things is, okay, fine, we'll just put a human in the loop to watch it. But that solution, it creates its own weird paradox. I mean, the logic seems pretty solid, right? Why can't we just have a person watch what the agent is doing, and if it starts to go off the rails, they just step in and stop it? Simple. What could possibly go wrong with that? Well, the short answer is no. It just doesn't work, especially not at scale. And the reasons why are all about human psychology. You have two big problems. First is alert fatigue. If you're constantly bombarded with notifications, you just start tuning them out. And second, automation bias. We have this natural tendency to just trust that the computer's right. We get lazy and stop double-checking its work. And this quote from the Partnership on AI really hits the nail on the head. Think about it. The whole point of an agent is to reduce human work. So if your agent is making thousands of decisions every minute, how could a person possibly keep up? It's physically impossible. So constant supervision isn't just impractical, it goes against the very reason you built the agent in the first place. So if sticking a human in the loop isn't the answer, then what is? Well, the real solution requires a totally new mindset for how we build these things from the very beginning. And here's the absolute key. The solution isn't about adding more supervision after the fact. It's about building better architecture from the start. The whole goal has to be building a system with constraints and layered defenses baked right in. Safety can't be an afterthought you bolt on at the end. It has to be part of the foundation. So what does that kind of architecture look like? This is a great way to visualize it. It's all about having layers of defense. First, before the agent even does anything, you have pre-action checks to filter out bad inputs and validate its plan. Then, while it's working, you're monitoring its actions in real time, watching for weird behavior. And finally, across the whole workflow, you have multi-step validation to make sure the agent is actually staying on track and hasn't drifted off from its original goal. Okay, so what does this look like in the real world, in practice? Well, it means doing things like ensemble verification, where you actually require a few different AI models to all agree on a decision before it happens. Or you could use a second AI as a judge to audit the first one's work. And some of it is just smart, common sense security, like forcing a reauthentication before any really high-impact action. And, super important, having a crystal clear definition of what done actually means so you can prevent those expensive infinite loops we talked about. Thanks for watching this series. Build carefully. AI is powerful, but only when constrained. And that really is the key takeaway, isn't it? Real power and reliability, they don't come from giving an AI unlimited freedom. They come from designing a smart, robust, and constrained system where it can do its job safely and effectively.